Complete tutorials on CAN protocol. This is the CAN protocol part 5 and the CAN hardware. So in this we are going to see about how the CAN hardware consists, or what are the microcontroller, what is the CAN core, where the register will be placed, everything will be see in this tutorial. And yes, this is a continuity of this previous tutorial. So this is the basic CAN controller diagram. So what are the CAN controller hardware stuffs consists? So here we have the CAN TX, then CAN RX. This is a CAN core, CAN controller. It's a core part. And what are the messages are transmitting? It will transmit from this pin. And what are the RX? It will receive from this pin. So this will not process anything. This will just send to this message. That is a message RAM, random access memory of 32 objects can be a accommodation capability. Then it will goes to the message handler, and in this the message handler will always prioritize or will just check for the CRC. Then it will transmit the message to the microcontroller unit. This microcontroller unit, say here we have given 8051 microcontroller. So this will keep on parallelly, this signal will goes to MCU as well as the registers. The register will always keep to the permanent storage memory as well as the temporary registers. Then this MCU will keep on process the data, whatever the data has been received here. Once it process, this process depends upon the programming has been done in this microcontroller. As you know, the microcontroller do the specific operation, so it will do only the specific operation. It will not do multitasking or multi variety of multi kind of data also it cannot do. Hence it will process the data what the program has been done. Once it has been done, it will just get sent to this registers, and by this way this message RAM can send to this CAN core. Then this will be transmit by using this CAN TX. So in this same way this happens. But one more thing is, this will not only, it will not only send to this, it will send to this also, because as all these controllers and all these boards has been interlinked, so one data has to be transmitted to all other mediums. Then here the basic, so we have two controllers, one is the standard controller, another one is the extended CAN. So they can, we can make it as basic CAN as well as the full CAN. So here you can see this. See here, this is a CAN bus. In this CAN bus, the interface is a microcontroller. Then here it is acceptance filtering. So why, first of all, the bus interface is nothing but the wire. This wire as transmit the data into the digital form. This CAN protocol controller has to check the message, as well as it will make the message to obey as per the CAN standards. So once this has done, then it will check for the filtering, is there is any harmonics or any noises present in this incoming signal. So if so, it will just make it filter, and it will allow only the what are the signals has been accepted. Apart from that, it will not allow. So this is what it called as acceptance filtering. And this acceptance filtering will directly goes to the receive buffer. So as obviously, if you send the bytes like 10010, then it will not send as a whole, it will always send as 101 like that. So this receive buffer is always gives the buffer time for the receiving data to also validate the CAN standards. Once this done, it will goes to the host interface, that is where you exactly want to transmit. Say for example, the CAN bus, here we have one node, say breaking node, and this breaking node transmits the data to the accelerate to the engine node. Means this, here the engine node will be the host interface. So it will goes to the processed data like this, and it will keep on count the TX and RX for the error confinement, to check for the error fault confinement. Then here it is can, it will also can see the CPU, CAN CPU as a low as or high. So it will keep on monitor the CAN bus load. Then once this module successfully receives this data, it will also transmit some data. So this will goes to the transmit buffer. So the transmit buffer is nothing but how the receive buffers receives the bit one by one. In the same way, the transmit buffer will also transmit. then it will goes to the CAN controller. So this CAN controller will process the data, it will goes to the bus interface. In the another side of the protocol, it will be same like acceptance filtering. It will filter and it will fetch to the receiver buffer of the another CAN controller, then it will send into the host interface. So this is how it will happen. And here the one more block is status and registers. So the status or control register is will store keep on store the data for the future reference or for the data refinement. So here the cheap CAN controller CPU could get overrun with messages if it didn't need them. So this overrun also will happen. So yes, this is another question. Why, how the overrun, or why the overrun in CAN? So it is the CPU could get overrun with messages even if it didn't need them. So if it didn't need them, or if it is the CPU load become high, then it will show the error as overrun. So this is one of the common error you may get. Then so this is a basic CAN controller, and this is a full CAN controller. The hardware messages filter sort and filter messages without the interrupting ECU. We'll see same the bus interface. Again it will comes with the acceptance filtering, then it will check with the CAN protocol controller. It will sends to the receive buffer as we have seen in the previous slide. And only thing is here we have n number of message object, that is the data occupancy is more than the simple CAN controller. Apart from the status control register is also same, and host interface is also same. Here the CPU indication also same. The only thing is we have n number of this message, that is the message object 1 up to n. How much you want you can do. If it want to transmit, as instead of this receive buffer, you can make it as a transmit buffer. So this is the difference between the standard CAN and full CAN. Mainly the full CAN has been launched in the perspective to send more number of data that can be achieved in the basic CAN controller. Then here the just a small example for the Caterpillar 797 system. So this is how the, it's not only for cars, it is a complete automotive vehicles can be used. So here, so in this Caterpillar 797 vehicle, so it have been, see this is the PC, this is the kind of PC, and this is chassis control, braking control, then this is a XMSN, then that is ABL 2C, then here a tire TPMS tire monitoring system, then this is a RAC, this ADEM, that is slave 2 slave 1, and this is a master of Adam. Here this is a kind of cluster. Okay, so this all these data can transmit and receive the message, or it can share the information to the instrument cluster so that it can display it in the dashboard. So this is one of the examples. See, in this we have 195 sensors and actuators, wireless data link. So wireless data link, so this is one of the advanced method where the Caterpillar has been reached and using it for the heavy vehicles, heavy duty vehicles. So in our next tutorials we will go with the frames in the CAN. So I guess this is one of the smallest small to short tutorial that you can easily understand about the what exactly inside the CAN device, that is a CAN controller. So we'll get back to you in the next tutorial with the frames. What are the frames in the CAN? And followed with that we have so many concepts like error handling techniques in CAN, then how the delimiter, how the CRC works, everything can be look upon the upcoming slides. Catch you in upcoming tutorials. Until then, bye.